Yeah, this is session 2AZ, simplified DB2 observability for DevOps. It gives me great pleasure to introduce a newcomer to the GSE and IDUG speaker circuit, Angelika Heinrich from Main Store Concept in Germany. Yeah, I've turned the waiting room off so people will come in immediately. So please don't forget your feedback sessions at the end, and please don't forget to donate to GSE's sponsored charities this year. I think Angelika has got a slide for that afterwards, but yes, here we go. Thank you very much, Angelika. All the best. I will monitor the chat for any questions.
Thank you very much, Marcus. Hi, everyone. So yes, my name is Angelika, and I'm happy to present a topic that I work on in close cooperation with my team and many other organizations who invest in mainframe technology. The title of the session, I think in the schedule, was really, really long. The gist of it, I've simplified as well. Simplified DB2 observability for DevOps. And that's what we're going to talk about today. But before we get into that topic, I just wanted to give you an overview about Main Store Concept, where I work. Main Store Concept has about just over 15 years of experience with enterprise storage and solutions for enterprise organizations. Our portfolio covers a wide range of requirements and is composed of products from our partners as well as solutions that we develop and maintain in-house. A large majority of those in-house solutions are geared towards modernizing, standardizing, and integrating mainframe technology. And normally, our goal with those solutions is to increase the value of existing systems by enabling capabilities that help organizations meet their long-term mainframe strategies. Some of the partners, at least those that are relevant to the discussion today, that we work with include Datadog, Splunk, and Instana, who is, as of late, also known as IBM. And many others. I've just tried to keep the list as short as possible. So let's get right into the topic. In the agenda, we're going to first go over briefly what DevOps is, and I'm very sure a lot of you will be familiar with what that entails, at least most of it anyway. We will then look at how observability fits into the DevOps toolchain. And then I'm hoping it gets a bit more exciting because we're going to compare observability to just monitoring as a term or a practice. And then we're going to talk about things like telemetry, traces, spans, and metrics. Something else that my team and I find interesting, something we work with and we wanted to introduce on this platform is the latest project by the Cloud Native Computing Foundation called OpenTelemetry. I'll talk more about that later, but we're very excited about it. And then I'm going to demonstrate and explain what we mean by mainframe inclusive observability for DB2 as well as other mainframe systems. But today we'll just focus on DB2 in various tools. Okay, and as Marcus mentioned, don't be afraid to post a question in the chat. If I don't see it, he will, and let me know. So what is DevOps? In my mind, it's the fusing of application development and operational responsibilities. So this means that the DevOps engineers are not only responsible for creating and deploying applications, they're also responsible for monitoring application availability, resolving incidents, analyzing performance, and a lot of other additional operational activities. DevOps, since it was conceived, I think officially around 2011, has evolved and matured through constant evaluation and improvement. And one of those evaluation and improvement activities is produced through a yearly report. It's called the State of DevOps report. And it's compiled by organizations like Puppet or Google's DevOps research and assessment program. The aim of these reports is to identify practices that result in technology delivery excellence. It's also a way for teams, so application teams like you and I, many people on the call today, to benchmark themselves against the industry, to identify constraints in the organization and also ways to improve. This year's report focused on the importance of meeting reliability targets, integrating security throughout the software supply chain, creating quality internal documentation, and leveraging the cloud to its fullest potential. If you read this assessment and a lot of other material regarding DevOps and DevOps performance for the organization, you will come across the term, the 5 metrics. These 5 metrics are collectively referred to as the software delivery and operational performance metrics. And they consist of the items you see on the screen: lead time to change, how long does it take before a new code is developed, how often are we deploying, so deployment frequency, how long does it take to restore services and applications after failure, the change fail rate, how often are changes resulting in failure, and reliability, newly introduced as a metric, but definitely something that cannot be ignored when we talk about the operational leg of the DevOps chain. Google analyzed these metrics and came up with performance profiles with different throughput and stability statistics. And those profiles are elite performers, and then we have high, medium, and low performers. And I've provided a screenshot of a tabulated form of the SDO metrics, so the service delivery performance metrics, and the performance profiles. And as you can see here, there are some interesting statistics and throughput that you and your team can also use to sort of compare yourself to the current industry. Some things that I want to highlight are the elite performance, obviously, because that's where we all want to be. Elite performers are able to deploy code multiple times a day. Their lead time to a change is less than an hour. Their ability to restore services after a failure is equally under an hour. And their change failure rate is 0 to 15%. The topic today, observability and monitoring, has been observed to play a very key role as well in the performance of DevOps. According to the latest reports, that would be 2021's State of DevOps report, elite performers who successfully meet the reliability targets are 4.1 times more likely to have solutions that incorporate observability into overall system health. So they are able to have end-to-end monitoring for all services across all tiers. So let's take a closer look at monitoring, and thereafter we'll have a look at observability. So application performance monitoring, I think everyone knows what it is. I'm just going to call it APM from now on. I've extracted 3 dimensions that have been defined by Gartner, and they were published in the 2020 Magic Quadrant for APM report. The dimensions of APM, according to Gartner, include the front-end monitoring. This is usually prioritized by users. So users implementing APM for the first time see this as priority number 1. Why? Because if you know how your front end, your end user experience, your digital experience is, you no longer have to rely on customers telling you when your applications are down, right? So you're proactively able to respond to any issues on the system. Front-end monitoring, I've already mentioned, it is digital experience monitoring these days. That's the new terminology, and includes things like real-time user monitoring, which is in essence a synthetic probe that is applied to be able to give us visibility into how end users are experiencing the systems. The second dimension is application discovery, tracing, and diagnostics. This is basically the automated discovery of servers, services, and microservices, including the runtime architecture modeling, so being able to see where services run and understanding service dependency to infrastructure. And that includes containers and orchestration support with Kubernetes, for example. And then last but not least, and definitely something that I think everyone should concentrate on as well when we talk about APM, is the ability to analyze, so analytics. These days, the APM tools provide artificial intelligence functions referred to as AI ops, so the ability to use machine learning to apply that to performance data and provide even more intelligence out of that data. When we talk about analytics, we're talking about correlating events, anomaly detections, and root cause analysis as well. There was a great article that was published back in 2012 by Larry Doggett. He was at the Auto Club Group, and it was published in the APM Digest. And what it is sort of like a cookbook for users implementing APM, either for the first time or as an official project in the organization. And I've pinned this in the slide in case anyone wants to read over that. He also talks about prioritizing these dimensions from Gartner and their approach. So definitely something I would recommend to read. Looking at the dimensions I've mentioned, we can see that APM isn't really, just monitoring. It's not just a dashboard with a graph and maybe a few alerts as well. It's evolved as well over time, and it's evolved with DevOps. It's evolved with that practice of agile methodologies to sort of cater for volatile workloads. We know that microservices architecture, things like Kubernetes or serverless microservices with Lambda, introduce volatile workloads. It's not always easy to replicate the same error or the same workloads. And that's why APMs over and above simply monitoring provide these additional capabilities as well. And these additional capabilities are a result of observability. So when we talk about observability, we're talking about a foundation of APM. I think if you're some engineers who've had any access to control theory or anything like that will probably recognize the definition provided by Wikipedia. I'll just read it out loud. It is observability is a measure of how well internal states of a system can be inferred by knowledge of its external outputs. This was really well translated by Steve Waterworth from Instana. To basically, if you are observable, I can understand you. I've also linked the article by Steve Waterworth here, which you can also get out of my slides after the session. But he used something called this pyramid of power, and that is exactly where observability falls into the realm of APM. So observability is the action of collecting outputs from a system. Monitoring is the process of processing that data and making it visual, understandable, turning it into information. And analysis is actually being able to ask questions. So we know what the state is of a system through monitoring, and analysis will give us the why is it that way. Jump back to the slides. I've also linked the beginner's guide to observability by Splunk, also a great read, lots of information in there. And in this presentation, I'm going to just extract the pillars of observability. What is required? None of these terms should be new that I think how it is applied is important. So we all know what logs and events are. Here described as immutable records of discrete events that happen over time. In this case, observability isn't just creating a log, but being able to provide that to an externally, so that another system can ingest and understand what's happening inside a system. Metrics are numbers that represent a process, and those are measured over time. And then we have traces that, in an APM perspective, provide us with the request workflow through systems and applications. So giving us request level information for each transaction. And again, I'm just stressing, even though none of these things are new, observability isn't just creating it, but being able to expose it to our external systems. And when we expose this data, we refer to it as telemetry. So metrics, traces, logs are telemetry collectively. And telemetry is the key to observability. So how do APM vendors provide that to us? They create agents or software that we install into our applications, onto servers. And those agents create traces, metrics, and logs and send them to servers, where they are processed and they create visualization of the data, alert us on events, and more. But there is a problem with that construct, because an APM agent creates proprietary traces. So traces or telemetry created by APM agent X can only be processed by tool X. It cannot be processed anywhere else. So this is a challenge that we face as users of APM technology. If we find another tool, doesn't always have to be APM, could be monitoring, it could be, for example, Grafana, and we want to integrate our systems with that tool as well, we may have to introduce new technologies or new software into our systems in order to be able to monitor our systems in a second tool. And that's why I wanted to talk about OpenTelemetry. So OpenTelemetry is a project by the Cloud Native Foundation, also referred to as CNCF. CNCF has been in charge of lots of popular projects. I think one of them, or one of the most popular projects we will know in this group, is Kubernetes. OpenTelemetry is an open source observability framework released version 1 in February under the Apache 2.0 license. Open source observability means you can get all the benefits of APM agents without relying on the proprietary agent of a vendor. So you get the traces and the metrics and the logs. Because it's open source and supported by multiple vendors across the industry, you have vendor neutral observability and multi-purpose observability, single source, multiple targets. I can monitor my system using one agent from OpenTelemetry in as many different tools as is required by my organization. On the right here is an overview of the architecture, which I will just go through very quickly. But in essence, we have libraries that get included into application programs or agents that are installed on systems, and they generate the traces and the metrics and send those to what are called OpenTelemetry collectors. And that is where the key lies, because in the collectors is where we configure the targets of our telemetry. Where do I want my metrics and my traces and logs to go? And that is where you can configure multiple endpoints. That can be existing APM vendors, for example, Datadog. It could be open source technology like Jaeger or Prometheus, and many more. So let's look at Jaeger. I'm just going to show you an example of APM traces, what it means, just so we're all on the same level as we go through the rest of the session. So this is Jaeger. It's an open source distributed tracing platform, in short, an APM, but open source. And I'm just using a very simple example just to explain what traces are and what they mean. Before I jump into the single trace, we can see on the top we have sort of a heat map. And this heat map is using the trace data to give us an overview of calls happening. So these are HTTP calls, and we can tell by the size of the circle, the amount of time spent in those calls. Right? So these here on the top definitely seem to take a lot longer than the ones here at the bottom. Looking at this dashboard, so we have a service called employee list. We don't need to worry about what that service is or does. We know that employee list is processed on a system called ZOS Connect. And we can tell from this trace that ZOS Connect uses DB2 to process that request. So from just this overview itself, which we can maybe akin to the metrics related to a trace, we know the tiers of the application call or the request. We know how long, how much time is spent on each tier. I can see how much time is spent in ZOS Connect, and I can see how much time is spent in DB2. I can tell just from this overview that in DB2 is where we have the majority of the time spent for this request. So, you know, at a very high level, if I was going to try and improve the performance of this request, I would probably first look at the DB2 part of the processing. Is there any way we could improve the SQL query? Is there any way we can improve the databases behind or used by that query before I even look at ZOS Connect, right? Let's drill down a little bit further, because traces aren't just time and place, they also have context. They provide us with more details. And those details are provided in what are called tags. Tags are searchable. It means when I provide a tag with a name and a value in all of my traces, I can find commonalities. I could find all the traces that have a request timeout flag, true or false, meaning an HTTP requests that have timed out. I could find all requests that use the same service name or come from the same client IP address, right? So trying to route requests or using the same method. Those are what tags are used for. They help us ask questions and to find answers to those questions. Other things that we can do with tags is give it system context. Where is it running? I can tell it the host name. In this case, it's an Alpar on ZOS. I can give it the architecture. I can tell it where the configuration parts are for this, where this service request was processed, and more. The job IDs of the ZOS Connect server that actually processed, and so on and so on. So this is what traces are. I've only explained a very small part of it because we're just doing the overview. I will dive into another demo shortly where we will look at a more sophisticated tool that really does take advantage of all the data within a trace. So, yeah. Just going to jump back to the slides. I'm hoping I haven't missed any questions. I don't see any, no. APM in mainframe. I've mentioned some mainframe things now in the demo, but let's just talk about it. Let's be honest, guys. There are very few APM vendors that support mainframe. And those that do come at a cost. It's expensive to buy the licenses, it's expensive to run it. Typically, they're CPU oriented, typically, not always, but typically. And what tends to happen is mainframe-backed companies say, well, you know what, we really like this tool and our DevOps teams are really excited about it. So let's just ignore the mainframe requirement and hope that at some point in the future, we get access to mainframe support in that APM tool. And that's okay. I mean, what else can you do if your budget doesn't allow you to buy a more expensive tool, or whatever else constrains you? I can understand going forward that way. But then there's a negative impact. And I guess it might be obvious, but I'll just explain it. So the DevOps teams then have this amazing tool that does all of this cool stuff, but every time there's a problem that may be related to mainframe interaction, they have to contact the mainframe SMEs. We're used to it, it's okay, right? Mainframers, they're like, yeah, I'll look in my Omegamon or whatever tools I use in my on my system and help you guys out. But it happens a lot. And it also means that those DevOps teams can't take full ownership of their applications. And it means that we're getting sort of lopsided performance from DevOps. For some applications that don't have mainframe interaction, it's great. You know, we can really start to add a response in an agile way to problems. But when mainframe is involved, takes a little bit longer, and we start to see reduced buy-in to DevOps culture, the tools, and any agile methodologies that have been adopted. What do I mean? I mean, it looks something like this. I've just painted this. This is in a screenshot, just trying to explain the problem. We have upper level service errors. As a DevOps member or a team, an engineer, I would be able to click into each of these components that I've got shown here. I could click on the services, the databases, etc., and drill down to issues. But sometimes there is the mainframe there, and there is an error that I'm getting reported from calls that integrate with the mainframe. And I have to swivel chair, I think is the term, to the telephone, call the team, send screenshots trying to correlate where those problems are using mainframe tools, etc. And it's even more tedious because mainframe isn't just a small system that does one thing. It's behind most of our core services, right? So in the end, we don't have insight, we don't have observability of our critical services. And that's where the value of having mainframe inclusive observability comes in. Talk a little bit about what I mean by mainframe inclusive. Just monitoring a system isn't enough. We've talked about that already. It's about getting a trace. The trace needs to be related to a request. It needs to have context. It needs to have data that we can ingest into dashboards. External to mainframe. We have great tools on the mainframe, but not everyone can access that or even understand it sometimes. There are terminologies used or integrated into those tools that are for experts, right? So if we could include mainframe in any observability tool, we would improve one of the biggest metrics, which is the time to restore, because we're already amalgamating mainframe performance data into a tool. We know where the performance problems lie. We'll have enriched dashboards with errors. So root cause analysis is no longer a call and an email and a MIM meeting. It's simply looking it up on the dashboard. So we know what the problem is and can get straight to solving it. Another thing that we think should be included into mainframe inclusive observability is obviously, as I showed in Jaeger, providing mainframe identifiers, giving you correlation IDs, system names, and things that mainframers can also use in specialized tooling for their own purposes, giving them more value, not just DevOps teams. And if you're using OpenTelemetry instead of a proprietary observability method, you're vendor neutral, tool neutral. It doesn't matter what tools your DevOps teams decide are useful, mainframe can be there if it's required. So, and it's not unusual. I can tell you from teams we've spoken to that the monitoring landscape in an organization is huge. It's not just one APM tool. We would like it to be that way, but it's not. They incorporate multiple tools to try and extract the most value out of their performance data and being able to respond to business requirements or any problems that customers face. we could reduce time. So time is money, we know that. And something else that's great about OpenTelemetry is being geared towards the future. I've included a quote here from Gartner's 2020 Major Quadrant for APM report. And here they predict at least that 50% of new cloud native applications will use open source instrumentation instead of proprietary agents by 2025. So you could also see it as an opportunity to maybe lead your organization into vendor neutrality or vendor neutral observability. Because this is where it's going. There are many reasons why there are benefits to this, not just for users, but when APM vendors themselves are no longer not cursed, but committed to having to create these agents themselves, there is already an open source solution out there that can provide more sophisticated user interfaces, better machine learning algorithms to give us more value from their tools, right? So those are some of the benefits to this. Okay, so I'm going to demo DB2 observability. What it includes or involves are IFC-IDs from DB2. If you're a DB2 administrator or user, you may be familiar with some of the data we will show. This is data that is normally locked away or only available to specialized tools. We've transformed these into traces and metrics and demonstrates what we mean by mainframe inclusive observability. So I'm going to use Datadog. It's a great tool. There are many others, but I'm just using Datadog because of the power of the integration. In essence, really, you could get the same value on any other tool. Traces are normally sorted into services, services being sort of the high-level operation. So you can see by our list of services what we have. We have some application names here, online banking, HR Online. We have some systems, DB2, OMBS, ZOS Connect, and TSO. How does that look? If we look at a service map, we can see how the applications talk to each other. We can tell what type of load, latency, and error rate those interactions have. On each tier, we can also see processes running that don't have any integration. We can see here that DB2 is in essence always at the back of a lot of things that happen on the mainframe. It's popular, it definitely fits into, I would say, modern application architecture, the service-oriented architecture very well. And so it makes sense that that is the situation. Here we have two different types of integration mechanisms. We have applications written in Java that use JDBC to access DB2 directly. And then we have other applications that use ZOS Connect, so REST API services being exposed, and ZOS Connect then transforms and adjusts that request for backend services, like DB2, batch jobs, kicks, all of that. So that's the map. All of this has been integrated into Datadog service map using OpenTelemetry. And the mainframe components here are also being observed using OpenTelemetry. So let's dive into DB2. Sorry, I had something in the way. Look at the DB2 subsystem a little bit and the requests that happen here. We can see things like the requests, errors, latency distribution, very interesting when you're looking at performance improvements and the types of calls that happen. We can see, we can do other things when we start to include mainframe, right? When we start sending traces, we can start creating alerts. We can automatically alert teams on events. It can be anything from when requests are using or consuming more CPU than we expect. We can alert ourselves on that. We can alert on erroneous events like deadlocks, for example. Let's have a look at the deadlocks. Just going to go to the last 15 minutes. Oops. Sorry, I can't get to the right screen. It doesn't matter, I'm just gonna go to traces. Sorry, I had to jump through the tabs there, but what we have here, I'm just gonna open this span list. So here's an application that's called HR version 12, HR Online version 12. It's also a JDBC application. I can tell by the types of calls it performs. It does pure select against a database, and that database is hosted on mainframe. And what we've done is used OpenTelemetry to turn IFC ID3 into a DB2 accounting trace. So I'll just open up that trace here and just explain that for you. And this trace contains, as we mentioned before, context. So we know what system it's running on. We know which LPAR. We can see the peer IP addresses that are registered by Db2. We can see other really cool things like the CPU time for that request, right? And in Db2 time versus ZOS CPU time. We can also see elapsed time and compare that to response time. So elapsed time would be the time spent inside Db2 processing the request. Response time includes the conversation, waiting for the application to respond or close the transaction. Other data could be the number of bytes sent and received, the types of calls, so lock statements, open requests, and prepared statements. And then some users also find things like workload management correlation interesting, being able to say, being able to monitor what type of workload service class is involved with certain requests. Does that have impact to my my services and the performance of those services? And depending on the tools, for example, here in Datadog, you can do some cool magic. So you can extract these tags and create dashboards. So I'm just going to jump over to the dashboards to show you what we've done. So we've created dashboards using those tags that I showed you. And the dashboard includes things like the average response time versus elapsed time and wait time. So the time for the conversation versus the time in Db2 and any latency in Db2 that we need to know about. I'll just expand that for you and go and drill down a little bit. What's great here is that when we've defined something like what are our average response times or how long do our applications should they take based on our statistics, we can start to create things like milestones or alerting thresholds on those tags on that data. And when you have tools like Datadog or any other tool that does similar, we could also simply click into the dashboard and find traces related to any information that we have found interesting there, spikes in CPU usage, for example. Other things that we did was create dashboards to monitor CPU utilization in Db2 and outside of Db2, as well as specialized engines like zips. Many reasons why this would be interesting to DevOps. There's chargeback. Using mainframe is not free. So when they have access to that information and have that knowledge, they can begin to start making more informed decisions about how they're interacting with mainframe, what type of performance impact do we have, and how could we improve it? Do we expect to have zip usage where we don't? Does zip utilization fall away at certain times of the day and make our applications more expensive? For example, those are questions that users can start asking. We also covered ZOS Connect and a lot of other mainframe systems, but for the time, I'm going to just stay on the DB2. But if you want me to provide you with a personalized demonstration of how we've done this, not a problem. You can reach out to me anytime. My contact details are at the end of the presentation. I'm going to explain to you how we did it and how it works. We have a ZIRIS client. It's a software product of ours, and that is installed on the mainframe. And mainframe's not alone, never forget it. It's being used by distributed applications all the time, creating workloads and producing SMF data. And that SMF data we stream in real time to a Kafka cluster. Kafka can be seen as another form of MQ, for example. It does event streaming for distributed applications. Offloading SMF to Kafka provides additional benefits like being able to use that SMF data in other in-house applications. Obviously, performance data with APM is a great use case, but SMF data is used for a ton of other things, data warehousing applications, for example. So having the data external to mainframe is another way you could remove data silos. It's also available in real time. So no longer having to wait for daily or weekly or monthly batch reports. That data is then consumed by our ZIRIS servers. There are nodes that consume data in real time. They're distributed and scalable, so you don't need one. You can have multiple to adjust the amount of performance data generated from the mainframe. And that server does a whole lot of cool things, including creating traces from mainframe SMF records and metrics. And those traces can be in various formats, including OpenTelemetry, which, as you can see from the graph here, is used to monitor other applications within the environment. And OpenTelemetry, as I have mentioned earlier, is supported by a lot of tools. So that means that mainframe is now a key player in some of the tools that your DevOps teams use and love today, including Zipkin and Prometheus that can be used with Grafana. You could even send traces back to Kafka that can be included in Splunk, all kinds of stuff, right? It's up to you. You're no longer sort of restricted to proprietary tracing mechanisms. And I'm pretty much close to the end of my time now. And I think I saw a question. So I'll just pop up my contact information here for a second, but my slides have already been uploaded, so you'll be able to get this on the GSC platform. And I'm very sure that Marcus will also ask you guys to submit feedback about the session at any time. I'd love to hear your feedback and I'd love to hear your questions. I see there was a question from Michael for a Db2 exception. Can you show us how to create a rule? Sure, I can show you. So this is specific to Db2. So Michael wanted me to just show how we do that. I'll open up the manage monitors. So for Datadog, it depends on the tool you're using. But basically what you're doing is creating a monitor, and the monitor, I should probably do it the other way around, but I'll open a defined one. It's a little bit easier for me. I'll just edit it. So how it works is you can say this is going to be a threshold, a change alert, an anomaly detection, or any outliers or forecast alerts, so the type of detection method you want to use. And then you define what metric you want to base that on. And that metric in this case is extracted from the traces, right? And you can say, how do you want to measure that using which application types? You can sum it up. I think you can also provide averages, maxes, mins, and so forth. And then you can define how to consider this an alert. The alert threshold is at 0, 1, 2, 3, 5 times before we get alerted. or do I want to be alerted on the first time it occurs? Who should I notify in that case? And what should I say when I notify? So that's how you would do it in Datadog, but again, it depends on the tool you're using. I hope that answered the question.
I've got a question.
Mm-hmm.
So do you run a Datadog agent on the mainframe, or is it your Z-Iris that runs on the mainframe and passes the SMF data to Datadog in the cloud? Is that where you're using Datadog?
Exactly. So the Z-Iris software or the client is the only thing that gets installed on the mainframe. The Datadog agent is not installed. So we are the bridge for Datadog to mainframe. It would be similar for any other tool. So for Instana, even for the traces you saw from Jaeger, for example, it would always be the Z-Iris clients installed.
So you trap the SMF records in real time and pass them, or do you have like an interval-based collection?
So it's real-time processing. The Z-Iris client is a Java-based client, so I didn't mention it, but it runs on zip processors, also just saving you time and money. But the Z-Iris client uses the IBM SMF real-time interface. So basically using those in-memory buffers to access high-performance records from SMF. So that there's no real big performance impact on the customer reading off of VSAM data sets, and two, that data can be provided in real time. When it's stored in the Kafka, it can be accessed by any application, including our servers.
Good, thank you.
Are there any other questions? I don't know. No. Okay, so thank you, everyone. I enjoyed being able to share this information with you, and I hope to hear from you if you found this interesting and you want to find out more.
Great, thank you very much, Angelica. That was really very interesting. And I hope that we will see you again in GSE at some point. Once again, thank you everybody for attending. Please don't forget to submit your session evaluation and to donate to GSE's sponsored charities for this year. Thanks everyone for attending, and I look forward to seeing you soon.